This little graph here, speed versus time. Got a lovely little shape there. How would we find the area?
Times one side by the other.
Times one side by the other. Seems legit. You going to put that phone away, Chloe?
Sure am.
What was that, Adam?
So distance taken, distance travelled and time taken, because that's, side the other.
So you got speed on one side and time on the other?
Yeah.
Yeah. So what, can we actually find the area with what we know there? Knowing that this here, sorry you can't see it, this is true, it's a quarter. Because apparently I did it too small. And this is 60 if you can't see that.
So a quarter of 60?
It wouldn't be a quarter, it'd be 20.
So it'll be 60 times,
Quarter of an hour, which is 15 minutes.
because isn't this 60 here, that distance there is going to be 60. And this distance here is going to be a quarter. And we know if we're going to find the area of a rectangle, we times the sides together. So 60 times a quarter? 15. And 15 what? We're going to go kilometres?
Oh yeah, because yeah, it's just
Well, let's just think. What's this? Speed multiplied by what? Time. And if we think back to really basic physics back in year 11, what's that equal to? Distance.
Didn't do physics.
So remember, distance is equal to speed times time.
Oh, no, it's not.
Or, yep. So km over h times by h. Is that what you're getting at?
Yeah.
And you can cancel them down, and so you're left with km. Yep, and that's fine because you're using your units. So you've got speed units, which are km over h, multiplied by your time units, which is hours, because t is in hours. Obviously your h's will cancel out, so you'll be left with 15 kilometres. Alright? Alright, so before I move on, do we have any idea how we could write that as an integral?
No.
No?
I'm going to be honest and just say no.
So if we were to, well, because we just found an area under a curve, so we found the integral.
Yep.
We did it in a different way, we found the area of the shape we know. But if we wanted to write that as an integral, how would we go about it?
We're going to write
You give a funny sign.
Well, we're going to have the funny sign, that's good.
Yeah.
The funny sign.
Would it be 0 and a quarter?
0 and a quarter, it will be.
That.
F of x, so it would be.
F of x.
Would it be f of t?
Well, I'm just thinking from the formula.
Oh, it's written on the graph, it's written on the graph.
It'd be the 60.
So it'll be 60.
And then it'd be dx, which is.
Well, is it dx or is it d something else in regards to dt? And it's equal to
15.
15. And you said you couldn't do it.
Can't do it.
Class
Well, we
effort.
didn't do it, you did it for us on there.
So what's that in terms
You guys stepped me
Is
through
that
it.
like in terms of integration?
I was being honest, I don't remember how you
So obviously the idea with this integration is, right now we're doing it so it's got nice easy shapes and you can find the area of them. What we're going to build up is build some skills so we can do it on shapes that don't have easy areas underneath and learn rules. A bit like all our differentiation rules. We're going to do the same thing because remember it's just going backwards.
Is it?
It's going backwards. So I suppose an application in regards to integration, nice and simple, and this is probably what we'll only be looking at today, is distance travelled is equal to the integral. Is that as blurry for you guys as it is for me?
It's alright.
Very
You
pixelated.
can read it.
So this here is T1 and T2. So distance travelled is equal to the integral between T1 and T2 of the velocity, provided we do not change direction. Alright, and we might have a look at some of that stuff. I think that comes up in a question down the track. Example time. So the velocity time graph for a train journey is illustrated alongside. Find the total distance travelled by train.
I remember.
So how are we going to approach this question?
So we're
What are you
done.
going?
And
Are we
we'll
gonna
put it
find
into
this-
different shapes.
Let's put it into different shapes. Sounds
Just about to say that.
bloody beautiful if you ask me. Let's just draw it a bit bigger because there's a bit small I think. So, don't hate my drawing.
Do you want me to draw?
Wow, it's not even straight. Try to tell me what
Yeah, it's not straight. Alright, so we know that, shall we say that this is shape A, shape B.
Yep.
Now, what are we going to do with that shape?
Split into two other ones. Like
Can we, or can we?
one rectangle.
We could do that, and if you want to do that, that's fine. There is also a formula for finding trapeziums. That's what it is. It's up to you. Which way you want to do it?
Do it as a triangle or a square.
Let's start off
trapezium.
easy, guys. Let's start off easy.
So, I mean, what Adam and Chloe are getting at is splitting it down here, I'm assuming?
Yeah.
Yeah, but I reckon I
A
think
trapezium
we're
is
gonna
just
one.
keep
If
the
you're
form.
going to use that one as trapezium, then you might as well keep A and B as one as well.
Or you can do that as well. There's so many ways you can cut this shape up. So let's just say, just so you guys are aware and you've seen it, I'll let you in on a secret on how to find the area of a trapezium, because I'm assuming no one's going to remember.
It's, I've got it right in front of the book.
Yeah.
A plus B over 2 times H for height.
Yep.
Yep.
So,
I totally don't look at the book.
So if we've got something that looks like this,
You can shut up. I'm not
No need for that.
so we've got A, B, and do you have H in yours, do you? In your formula?
Formula, it was bracket A plus B divided by 2 over H, so I'm assuming you get taking height to account.
So area is equal to A plus B 2 times C in this case. But obviously the one you had I think was on the other angle, so it was rotated 90 degrees. Alright, so let's just add some other things on here. Well, we know that this is going to be, how long is that going to be? That one, how long is that one going to be? And I think the rest of them are going to be 0.1, aren't they?
Yeah.
So you get the idea. And then we need to figure out some heights. So I think we're going to have 50. 50. Yeah, maybe draw yours nice and big. Then I think it drops away to 30.
Oh my god.
And then 30.
What was the area of the trapezium again? Because I hadn't had it written down because I was writing the graph.
A plus C.
Just do that for a second.
Just 2 sides times.
What other questions, please?
1, 2, 3, and 5. A.
Shit.
So 1, 2, 3, 5, A.
5A is an extension.
Why not 5B?
It's 5A's enough. You can do 5B if you really want to. I know how keen you are.
Because we've got glass. I'm not going to do it.
Chapter.
6. 6A, 182.
C plus 30 divided
So this was A,
by
B, C. Oh, did they end up doing that's D? And I'll have to go to another line.
So make you sad.
Yes.
Whoa,
Sorry. Just ignore it, Adam. Just don't look at it. Keep going.
Just looking too bad.
Now, if you put that in your calculator correct, hopefully, we should have got 21. Now, is there anything we need to clarify through that? Are we alright over there, girls? So remember this was, A was a triangle. I think A and E were triangles. So remember the area is half base times height. Then we had, I think this was a rectangle, which we know is just length and width. Then we had our trapezium. A, B, C, I believe. And then we had another rectangle. Wow, now I've just made it look really bad.
Yeah.
It's because they're triangles. B was a rectangle, C was a trapezium, and D was a rectangle. And that's how we got all those numbers.
Like that.
Let's get rid of that. Oh, I can't get rid of it. It's annoying. So you should have found, for each of the individual ones, you would have got, I think, 2.5 for your triangle for A, plus 10, plus 4, plus 3, plus 1.5. So A, B, C, D, E. If you split it up and calculated them individually and then added them up. And I've left this so I can do this. The integral of t take 3 to find the displacement. Now, what's the integral of t take 3?
Shit, I forgot how to do it already.
Same.
Anyone remember?
Wait, is this the one where you go up?
You're integrating it.
Is it t squared? Half
Actually,
t
you
takes
forgot
3
it.
to power 2.
You've even forgotten.
Close.
Well, half t squared take 3t.
That'll do. What are you missing?
dt. Plus c.
We go away on holidays for 2 weeks and we forget everything.
And you almost died.
No, I
We
almost
have
died.
2 weeks before exam starts. We're gonna kill ourselves.
Yep, 4 weeks before your exam though. After his holidays.
Good.
So we've got that. Now the displacement in the first 4 seconds is S4 take S0, which is equal to negative 4 centimetres. Now if we were to actually calculate that, you'd obviously have, what would you have, a half, 4 squared, take 3, 4, plus C, minus, obviously, naught, it's going to just be naught. Because if you sub your noughts in, so then your C's are going to cancel, and then you're going to be left with. So the C's will cancel out, you'll be left with a half, 16, take 12, which will be 8 take 12, which will be equal to negative 4. If you're wondering how to get that answer. That's a really bad M. And that was a really quick explanation. Alright, so that's a displacement which they may ask you for, but the majority of these questions, if not all of these questions, are going to ask you for the total distance travelled. And this is not the total distance travelled because of the reversal of the direction at t equals 3 seconds. Now for anyone who doesn't do physics, or even if you do physics, there is a difference between displacement and distance travelled. The displacement is how far you are from your starting point. Distance travelled is how far you have travelled overall. Alright, so we find the position of the particle at t equals 0, t equals 3 and t equals 4. And therefore we can draw a diagram of its motion. So at s equals 0, all that you're left with is c. At s equals 3, so if you were to sub 3 in, you'd end up with c take 4.5, or 4.5, and s4 is c take 4. So this is obviously at t is equal to 0, so 0 seconds. Then you've got 3 seconds where it reverses, remember, and then you've got it at 4 seconds because we're trying to find the total distance travelled over 4 seconds. So what will happen in regards to the motion of this diagram, if C is essentially your origin, think of C as your origin, like your 0 point, because C is common to all, it's going 4.5 backwards at 3 seconds. So this is at 0 seconds, this is at 3, and then that is a 3, believe it or not.
Really bad one.
Yeah, so that's at 3 seconds, and then this is at 4 seconds. So it turns around, and for another second it starts to head back. Alright, now thus the total distance travelled is 4.5 plus 0.5, which is equal to 5 centimetres. Because if you think about it, if C is kind of like your origin, it's gone 4.5 this way, has it not? And then it's gone a half back this way because it's gone from 4.5 to 4. Alright, so it's actually travelled 5 centimetres, and this is clearly different to the displacement of negative 4.
Is it straight line for temperature?
Yeah, I don't know.
Cool. So a particle P moves in a straight line with velocity function vt is equal to t squared take 3t plus 2 meters per second. How far does P travel in the first 4 seconds of motion? So I might give you just 30 seconds to quickly jot down that question so that as we go through you guys can really follow what we're doing. Alright, so feel free to have a go at this by yourselves as you go along. Otherwise, if you want to follow me, that's fine. What's the first thing we're going to do? Draw a sine diagram. Now, how are we going to do that?
Equal it to 0. And then we have to
Yes, but is it in a form of where it's easy to find what t is if we equal it to 0? So we want to factorise it. So VT, it's going to come up everywhere, Chloe.
still hate it though.
So if we factorise it, what's it going to become?
T take 2, T plus 1, or T take 1 and T plus 2.
No. T take 2.
It's only got a equation. Oh, that's right, yeah.
Because we need to get the negative 3. So it'll be, that will give us a negative 3t, and then the negative 2 and negative 1 will give us the positive 2 on the end. Alright?
Oh, I'm going to write that down. This is not option.
But does it make sense to you, Chloe, on why it's t take 2 and t take 1? Good. Otherwise, if not, that's okay. We'll just go back and practice it. So now if we had a sine diagram.
Because isn't it times to get the n1?
So times to get the end one and add to get the middle one. Yep, exactly. So if we've got a sine diagram, what are our critical values going to be on a sine diagram? So yep, 1 and 2. Because it's when these parts are equal to 0. Do we remember that? Now, how do we determine if it's plus or minus?
Sub a number.
So let's say that t is equal to 3.
5, it's easy.
What's wrong with 3?
There's nothing wrong with 3.
Oh, I changed colour without even meaning to. So now we've got 3, take 2, 3 take 1. It's obviously going to give us 1 times 2. It's going to give us 2, which is going to be greater than 0, yes. So it'll be plus, minus, plus. Now why is it plus, minus, plus?
Because it goes in like row.
Yep.
Alternating.
There's no squared. If there was a squared function, just for fun, make sure you guys are on it. If there was a squared here, what would that make the sine diagram?
Minus, minus.
Plus, plus, minus.
Plus, plus, minus. Because that squared is affiliated with this negative 2, which is affiliated with that sign, or that number. Oh, I wanted to erase that.
That makes sense.
Alright, so what about then? If we put the squared on this one,
Then it'd be what we said.
then it would be your plus, minus, minus. Alright, good. Just keep making sure we remember that stuff. So if it comes up. Okay, so what does that sine diagram mean then?
Points at where direction.
So P reverses.
We changed twice, direction twice.
Yep, direction at t equals 1 and t equals 2 seconds. Yes. Beautiful. Step 1. Complete. Step 2. What do we do in step 2?
Determine ST by direction.
So we're going to find ST by integrating. Now, when you integrate, go back and use your expanded form.
Yeah.
Because it's much easier to integrate. So t squared, take 3t plus 2 dt. Now, we integrate that, what do we get? So t 3 on 3, take
Like 3 on 2 to the square.
plus c. Don't forget that pesky plus c. Step 2. Done. So we've got to find S naught. Yes?
Yeah.
So that's SA. What's that going to be equal to?
0 plus
So it'll be C, won't it? I should just write this out again. So S of t, everyone playing at home, is T3 and 3 It's take actually.
Has Sam left this group yet or not?
I have no idea.
Oh, I thought and he said that. I think he said that he was doing that. I'm not sure.
Let's just make sure we're doing this for the moment. 3t squared, that's squared on 2 plus 2t plus c. Alright, so then what else do we need to find?
SA and SB, so they're the two values you just found, aren't they?
Well, that's S naught. S naught's one of them. What's the other one? What's SB?
Is it S1 or S2?
Well, let's just think. When it says find SA and SB, A and B are the beginning and end points of time. So for us in this question,
Oh, so
it's from
it's
0
S4.
to 4. So this is SA here. So let's find SB, which will be S4.
And then it also says anytime there's a direction change, then you have to do 1 and 2 as well.
Yes. So S4 is then going to be 4 cubed on 3. Take 3, 4 squared on 2 plus 2, 4 plus C. Which, for anyone, is going to be equal to 64 on 3, apparently.
I feel like close enough is good enough. Where's the C? Oh.
Still there. There's going to be take, what's that going to be? 24 apparently, so we get to, right, that's going to give us 48 on 2 plus 8 plus C. So obviously that's going to give us 64 on 3, take 24 plus 8 plus C, which will give us 64 on 3, take 16, won't it? Plus C. Now we need to combine these fractions.
You make 16 over 3.
So you have 64 over 3, take 16 times 3. So 48 on 3 plus C, which will give us,
Sorry, what did you do there?
change to 16, so it was 48 on 3.
Oh, yeah, just...
So times both, well, times 16 by 3,
Alright.
so give it 48 and then divided by 3.
Alright.
So they're both common denominators of 3.
Alright.
So then you can have 16 on 3 plus C, which if you really wanted to, you could say is 5 and 1/3 plus C. Okay, now you can do a lot of that straight on your calculator. I think calculators are powerful enough to leave things in fractions, so it's up to you, but also remember it is good to know how to do fractions. So as I said, this is SA, which is the first time, so from 0 to 4. This is SB, and then you need to find your reverses, where it reverses, and that was S1, S2. Has everyone got what they wanted written down from the slide?
Yeah.
So you guys can probably sit there and try and figure these out, but S1 is equal to C plus 5 on 6, or 5 on 6 plus C, and S2 is equal to C plus 2 on 3. Alright, so then if we want to do a motion diagram, remembering that S0 was equal to C and S4 was equal to C plus 5 and 1/3. Alright, so we want this. We're going to have C here. So for the first second, it's going to come up to here. It's just going to be...
This is technically step 4.
Oh, we're drawing the motion diagram? Yep, so this is 4. So C plus 5 on 6 for the first second. It's then going to reverse direction at that, and it's going to come back to C plus 2 on 3. And the second it reverses again. It's going to reverse here. And then it's going to finish at C plus 5 1/3. So this is 0 seconds. 1, 2, 4.
You just assume it's like 2 just goes there. I think then.
Oh yeah, I just made that up where it needs to go. But obviously because it's going C plus something, it's going to go to the right hand side. Now, how do we go about determining this total distance travelled? Any idea? So, I look at each individual part. I'll show you the way I do it, and then I'll tell you where it is in the book, and you can have a look at which area you prefer. So let's just say C is technically the origin, so it's 0 in some cases. So C is always 0. So really, this is travelling 5 over 6 there, isn't it? So for that first part, it's going 5 over 6. Then we want to add this part in here. What's that part in there going to be? Maybe I should do it in pink. So it'll be 5 over 6. Take 2 on 3. Beautiful. And then we want to do this part here.
2 on 3 plus 5 on 3.
Not quite.
Is it 5 on 5, 1/3?
Yep.
Take 2 on 3.
Exactly. Does everyone see how that works? Or are we still a bit confused? Because really what's going on, if C is 0, the particle here has travelled 5 over 6. Let's just say it's centimetres. So it's travelled 5 over 6 centimetres. Then it turns around. Imagine it turns around back on itself, so there's not these little actual bits that you need to figure out. It turns back around. They are so mature. I don't know, I saw Brad Dempsey, but he wasn't the one that opened it. It turns around, and then it travels back here. So it's gone from 5.6 to 2 over 3, essentially. So if we know that this whole section here, where can I draw this without making it look really bad? Yeah. So we know that's 5.6, but we actually want to take away 2 over 3. So it's just that little bit. So then you take away your 2 over 3. Then when you figure out this last bit, well, we know that whole area there is 5 and 1/3, but we want to take away 2/3 again. Alright?
The 2/3 that.
This one here. Because it's only from here to here. That last section.
So all those numbers are just the distance from the origin?
From the origin, yeah. Well, what we're saying from C, which we're calling the origin. Because it's it. All the C's, if you include the C's in it, which it does, on bottom of page 202 is where this example is, they've included all the C's and every single C will cancel out. So if you had originally C plus 5 on 6, take C, because C is where you're starting. So it's whichever way you prefer to look at it. I think this is an easier way.
So what have they done? C plus 5 on 6, take C.
So,
and C plus 2 on 3, take C. Something.
Yeah, so they've done for the first part, for this part here, which is technically that first part, they've done C plus 5 on 6, take C. Because it's kind of like saying that all of this area is C. So they've got rid of it. But then the C's cancel out.
Yeah.
So it depends which way you like to look at it.
How did they do the second bit?
So then they did, for this, so that bit in pink.
Yeah.
They did C plus 5 on 6, take C plus 2 on 3.
Or they did the taking bracket?
Take with the whole, this whole thing
Yeah.
in brackets. Which will means your C will cancel out because it'll be C minus C, and you'll be left with 5 over 6, take 2 on 3. But have a look in the textbook, bottom of page 202. So then if we have this, so we need everything in regards to 6's, aren't we? So we're going to have 5 over 6 plus 5 over 6, take 4 over 6 plus, what's that going to become? So it's going to be 16 on 3, which is going to be equal to 32 on 6, I believe, plus 32 on 6, minus 4 on 6. Sorry, that's so squished in. So let's add those all together. So we've got 5 plus 5, take 4, plus 32, take 4. Hopefully I've done this right, because that gives us 34 on 6, which will give us
17 on 3.
Yes. On 3, which I think in the book they've got 5, 2 on 3, which is the same. Yay.
Is it really? I don't know.
Yes, because it's travelling in metres per second in the question.
I don't know, so I wrote units.
Units, that's alright. But try and, link it back to the question.